today. So first of all, I would like to welcome Dan, who is going to be talking to us all about what life might look like living on the moon and how we're going to learn a little bit more about it. Here you go.
Hi everyone, my name's Dan, and do I have slides? There we go, cool. Yep, so my name's Dan, and until recently I was a PhD student at the University of Kent. I've now finished that, and I'm going to be talking about deep learning in deep space, so how scientists like me have been using AI to try and explore the moon and Mars with satellite data. So I thought, because a lot of you are sort of sixth form age, I thought I'd give a bit of an introduction to my background. So I'm originally from a town called Saltash, which, despite what the Union pub says, is actually in Cornwall. So I did all my GCSEs, A-levels there, did physics, maths and French, but still didn't really know what I wanted to do at uni. That was until I did my sort of last final open day. My mum said that's the last one she's driving me to the University of Kent, where I actually did a master's in astronomy, space science and astrophysics. So it's an integrated master's, so you do it all in 4 years. And apparently I liked it so much that I stayed on to do a PhD there. So in total I was there about 7.5 years. So I definitely know where all the pubs are in the Uni of Kent. But oddly, doing a sort of space sciences PhD, I've now found myself working at Kew Gardens. So I'm actually working in the spatial analysis team there, so trying to map at-risk ecosystems with machine learning and satellite data. So whenever someone tells you that, you know, we shouldn't be focusing on space sciences and space exploration, we should be looking at Earth, you absolutely need to do both. You can't do Earth observation without the satellites that were put on rockets to get up there. So yeah, that's a bit about me. So like I said, I'm talking about space data and AI. So I thought I'd gauge a little bit of how many space missions you guys might know. So if anyone wants to shout out any that they've heard of, I can try and point them out on this pretty plot that I've made for you guys. Literally shout out any. You don't have to raise a hand or anything because I can't see any of you. Yeah, thank you. So Voyager's at the top, so you can see that it's actually lasted up until present day for, I think, 48 years, I think's right. So it's still transmitting data, and Voyager's seen loads of different planets throughout the solar system, and it's now actually sort of feeding us back data about what it's like outside of the solar system as well. So like intergalactic medium and things like that. So do you notice how like much more dense a lot of the space missions are towards the like 50s and 70s? So there's loads of moon ones here, loads of sort of Venus ones, Mars ones. So that's obviously because that's when the space race was. So a lot of focus was on trying to be the first to do something. So a lot of these were like flybys. So people would send a little probe to just go fling past a planet or a moon. Whereas now you've got a lot of like longer lasting, a lot more, you know, in terms of like frequency space missions that are doing sort of more in-depth science. So they might be looking at the surface, so trying to take photos of them, looking at like the magnetosphere, the sort of strength of the magnetic field of these different bodies, their atmospheres as well. So like Mars has an atmosphere that we want to try and understand. So there's a lot more sort of more complex missions compared to what we had in the space race that are giving us all sorts of different data back. So speaking of sort of the early missions, oh, actually, so there you go. There's Voyager. It's a little image of it. There's a Perseverance rover. So if you've seen that, it's got an Ingenuity helicopter as well. So that's an autonomous helicopter that's flying about on Mars, which is really cool. And then you've got the Saturn V. That's what the Apollo astronauts went to the moon on. Does anyone recognize what this might be? Speaking of space data, I wouldn't be surprised if you didn't. This is actually the first digital image of another planet. It might not look like an image. That's because it's hand-drawn. So this was from Mariner 4, which is one of the first missions to Mars. It flew by and took some images, but the engineers at JPL were so excited to sort of see what it looked like, they don't want to wait for the data, the image to sort of get produced. So what they did was they printed out the pixel values and colored them in, like paint by numbers, and then stitched it all together to form that image. So you can actually see this is sort of like the space in the background, and then you've got the edge of Mars here. And if you sort of Google what the actual photo looked like, they're pretty bang on, which is quite cool. So you can see the sort of things people had to do to get around the issues with like early space missions having to literally color in the image. Thankfully, we don't have to do that now. So I made these little videos showing that the moon and Mars have both like been completely imaged, so we can see the whole way around the surfaces. However, now we have sort of a different problem, and it's weird calling it a problem because it's a good one, is that these images that are shown on the sort of spheres here are about sort of 100 meters per pixel. So like if this Royal Institution was on Mars, you'd probably be able to see it. Whereas there are satellites, the Mars Reconnaissance Orbiter, the Lunar Reconnaissance Orbiter, that are taking photos of these bodies that can see like 25 centimeter per pixel resolutions, 1 meter per pixel. So if your car was on the moon or Mars, you'd also be able to see it. And there's actually 2 million of those high resolution images of the moon. So that's way more than any of us would have time to go and sift through to see what's there. So this is the problem that I mean, is that there's so much data coming back from current space missions that we need automated methods like AI to be able to look through them and see if there's any cool stuff there, which obviously there is, because the moon's cool. Now, I promise there's a bit of context to this image. What are these? This is meant to be easy, don't worry. They're geese. How do you know they're birds or geese? They got wings. Yep. But what's this? This has wings. It's a plane. How do you know it's not a bird? Yeah, it's made by humans, made of metal. You can see it's got engines. Then what's that? It's a cat. It's got whiskers, it's got ears, it's got a little pattern. Then what's that? It's a lynx. Well done. So it's a different kind of cat. So what you're doing with all these images is you're recognizing patterns in these images that you've seen before. You've seen loads of cats, you've seen loads of birds, you've seen loads of planes, and you're using that experience to try and make like educated guesses when you see new stuff. So especially with this case, not everyone knows that this is a lynx. I didn't when I first saw one. So this is exactly what we can do with machine learning. You're giving computers loads of examples of stuff, saying what it is, saying if it's an image of a cat, an image of a lynx, or a bird, or a plane, and eventually, over time, it will be able to learn to recognize the same features that you just did, whether it's got ears, whiskers, wings, made of metal, things like that. So that's what I've been trying to do with satellite data of the moon and Mars, so that if I then look at images like this, so these are real NASA images of the left is the moon, the right is Mercury. What do you think these might be? Yeah, the craters. So you can recognize that from the fact that they're sort of circular, they look like they're depressions, they're casting shadows. So you're doing the same thing. You're recognizing patterns, features, sort of characteristics from these images and using your experience to sort of guess what they are. So that is exactly what I've been doing in my PhD. And I'm going to talk a little bit about one of the projects that I did, which was trying to use deep learning, hence the sort of name of the talk, to look for cave entrances on the moon using satellite data. So if I carry on. So you might have seen that caves were actually in the news somewhat recently. I think these posts were like from a year ago. So this is quite a famous cave on the moon. It's called the Mare Tranquillitatis pit. And this is actually in the same sort of region of the moon as where Apollo 11 landed. So Mare Tranquillitatis is just Latin for Sea of Tranquility. And these caves could be really useful for future exploration. So if you're sending humans to the moon, to the surface of the moon, or even robotics, having this like natural shelter from radiation, from the sun, from the cosmic microwave background, but also micrometeorite impacts, because stuff's constantly hitting the moon that you don't really want to be under it when it lands. So being inside one of these caves would be really handy. And with radar data from one of the space missions that were deployed just a second ago, people found out that this is actually a cave. So there's a cavity underground that people could like go and explore and build a habitat within, which would also be great for looking for water ice as well on the moon, because there's definitely that there. It's just looking in the right places to find it. So that is exactly what I tried to do with this sort of AI model. So this is called a mask RCNN. You don't need to worry about that too much. It's a type of neural network. So this is where we get the name deep learning. It's a stack of layers, very deep, so loads of layers, made up of things called neurons. So they work in the same way that the brain operates. Like when you get enough of a stimulus, your neuron activates, and then you sort of recognize what you're seeing. That's exactly how a neural network works. It sort of replicates the brain. This is a type of neural network which gives you like a bounding box around the thing that it's detecting, so in this case vehicles, but then also like a prediction of where it is within that box, and that's sort of the reason why I picked it. So instead of training it on images of vehicles like these, I was training it on satellite images of the moon, of known caves like the one I just showed before, to try and find new ones elsewhere in the surface that people maybe haven't looked, or where they have already looked to see if they've missed anything, which is exactly what we found. So with our trained model, which was actually called ESSA, so ESSA, Entrances to Subsurface Areas, I also called it that because that's the Cornish name of salt ash, the town that I just showed, we found a potential cave entrance. So this is in a region called Marius Hills. This is cool because you can actually see there's loads of potentially collapsed lava tubes, so a lot of cavities that people could go and explore and use for lunar bases. And we found a potential cave entrance within this region that had actually been already mapped. So people had looked through here before and had missed this feature. So I think part of the reason was that it's very low contrast. You know, you just see a sort of shadow there. But then when I found a new image with the sun pointing in the opposite direction, you can clearly see that there's some sort of cave entrance here. So it proves that using AI can actually help us spot things in areas we thought we'd already checked, which is quite cool. So this would be a really good place for a lunar mission to go look for caves and to actually explore them. There was a proposal called Moondiver to actually like abseil a little robotic spacecraft down into one. Unfortunately, that wasn't successful, but you never know. It might come back around. And this is another one that we found. So we found two new cave entrances. This one's really cool because it's so high latitude. This one's really close to the North Pole, as you can see up here. So it's inside a lava-filled crater called Belkovich A. And when I first saw that the model detected it, I thought, that's a bit weird. Like, that's a very odd shape for a shadow to have if this was just a regular impact crater, because they're meant to be sort of bowl shaped. So when I sort of found a higher resolution image, you can then see that there's some sort of overhanging rim suggesting that it might also be a cave entrance. So this could be really cool because the further sort of closer to the poles you get on the moon, the more shadow you get, because the sun's so like low on the horizon, that this would be a really good place to look for water ice because it's so constantly covered in shadow. So I was very pleased when that got detected. So yeah, that's a little bit of how AI is being used. I like for something that's more positive than it sometimes gets in the news. A lot of the sort of AI use tends to be quite terrifying, but it can be used in examples like this for finding cool stuff on the moon. So yeah, thank you very much, guys. And I thought you might find some of this information useful. So if you want to get into space sciences, there's things like different societies or different courses that I know exist. And also like internship opportunities and stuff. I'd definitely recommend doing all of that. So yeah, thank you very much, guys.
Amazing. Okay, thank you so much, Dan. That was so interesting. And yeah, it is kind of nice to see some nice examples of AI being used. I think it's really interesting as well.